right, go. Too dark? No? Okay. Sometimes this side gets a little dark. Okay, so just to ask you to put it in interval notation, we can do that to solve just a basic inequality. A couple of them are just real basic. This was their compound and statement. Just to get you to see the compound and statement can be solved simultaneously. So if you struggle, just look at one side. So you're going to add 6. You're going to add 6 to all the parts. And then you're going to solve your and statement while it's built up all together. And then just write it as an interval. Just to get you to see that you can do that. I know some of you didn't solve it that way. And you can absolutely separate them. That's fine with me. Whoops. I can't play with this too much. Right, so now, you have an or statement. You factor. Those are your critical values. Those are not just your only answers because this is an inequality. Put your critical values on the number line and test. You can... Question? Oh, I'm sorry. You can put this in your Y1. You can test to the left here, to the middle, to the right. You can say this is a parabola, quick way. This is a parabola that goes like this. Don't forget, this is just the x-axis of your coordinate grid. So if you want to, put the other axis in there so that you can see it. Anything that drops below, when you look for a value of a function, you're looking for the y. So you want the y to be positive, anything greater than 0, or equal to 0. So you want these guys right here, where the y's are positive values. We don't care what the value is, as long as it's positive. So if you superimpose your quadratic onto here, it works the same. Give me your answer, interval notation. Everybody's good with that? Stop me if you're not. Okay, number 7. Quadratic again. If you superimpose your quadratic on here, here's your quadratic. You want the ones that are less than 0. You want the negatives. So you want anything that dips below that x-axis. It's on your coordinate grid. That's where your y is negative. If you sign into the late sheet, thank you.
Is there a pen?
One time,
Yeah.
got it. Okay, good. Answer in interval notation. Again, we've got an or statement. Factor it. Those are your critical values. Test. Your parabola again is opening up. So those are kind of nice with the brackets there, the quadratics. They're either going to open up or they're going to open down. Number 9. You have an or. Again, put your parabola out here. Test. I tend to overkill the work on the board just so that if anybody did that type, they got it. If not, whatever works for you. I would put the parabola there. Not everybody sees that, so I try not to. Here's another one with a parabola. You're looking for where is it negative. It's kind of nice because when you see the negatives, they just drop below the line. And when you did this in Algebra 2, they tended to shade the whole thing in. I don't shade the whole parabola in, but I just shade the line in. Can everybody factor that one? Any problems with the factoring? No? Okay. Again, there's a nice one. There's parabola again. Test your center, test each part. Don't put your 0 out there. Remember, don't put your 0 on your number line because then it's going to make you a different interval. Just put your critical values and test. This guy, this tells me I have 4 roots. I hit that axis 4 times, or I could be imaginary roots. but I have 4 roots. When you come here, this one is a double root. If you wanted to graph this without your calculator, all of your evens work the same. They work just like a square, like a squaring function. So when it's positive, the ends go up. So your ends are going up. It has to come through here. What happens at the 0 is it has to bounce off the 0. It can't go through the axis because it's a double root. So it's going to come like this and make some kind of a W. Whether it drops down on one side or drops down on the other side, that we don't really know yet. We'll figure that out soon. But it's going to look like this somehow and cross over. Whenever you get a square, that's a double root, and that doesn't pass through the axis. It bounces off. So that's why these two guys were negatives. Now, be careful because you also wanted the greater than or equal to 0. You want it to be equal to 0. So you need this point right here because it is equal to 0. So give me this part, negative infinity to negative 2. Jump over all the negatives. Give me the 0. And then from 2 to infinity. Okay? Okay. Questions at all on those? I didn't do a whole lot with them. So let's take a look at what these are. The rational expression has a fraction in it. And what we want to do is, because it has a fraction, the first thing we have to do is find any domain restrictions. Because it's an inequality, we're going to set the inequality to 0. Try to leave your rational expression on the left-hand side. This way, the reason for doing that is then your number line makes a whole lot more sense. We can read it left to right. Find a common denominator. This is key. You need to make everything into one term. Then life gets real easy. You find the zeros of the numerator. You find the zeros of the denominator. Those are your critical values. And then you're going to test your intervals. And you're actually going to have to do some testing in here. And then you're going to write your solution as an interval. So let's try this. I'm not going to do the first. Let's do the second one first, if you don't mind. The second one we don't have to move to any places. Okay. So the second one says, do we have any domain restrictions first? Okay, so let's factor this. What does the numerator factor into? How about the denominator? X plus 5, x plus 3. So my denominator is where I'm going to have an issue. I can't have it equal to 0. So for my domain restriction, the first thing I'm going to do is set these guys equal to 0. We can't have a negative 5, and we can't have a negative 3. So my domain says take that out of here. Negative infinity to negative 5, jump over it. Negative 5 to negative 3, jump over it. And negative 3 to infinity. Okay, there's our domain, our restricted domain. The next thing we want to do is make sure everything's to one side, which this one is. It's just one rational expression. And we want to find out where this is positive. So let's take a minute and put this on our calculator. Because what's going to happen is, when we hit x is negative 5, when we hit x is 3, negative 3, it's going to break your graph. So that's where your asymptotes are going to be. So your graph is going to be kind of like looking a little strange. So we're going to graph this guy. Okay, so just get this in your calculator, get a feel for what it looks like. You can use these calculators during class. don't have to sign them out or anything. Just take one, put it back at the end of the period. Okay, oops. It's every man fend for themselves, huh? Okay, so we're going to graph this. Okay, so at the -5, we could see it do something. At the -3, we could see it do something. -5 says you get an error. -3 says you have an error. The -4, I can't really see where that is right now, but I know there's something over there. So I'm just going to change my window and make my Y go down a little bit further, just so that you could see where it is. Because there is something down there. See it? Okay. So as we go through this, as this course gets rolling, we'll find all our asymptotes, we'll find all our end behaviors. We'll do this without your calculator. But for this section, since we haven't done that yet, we're going to be using your calculator. So right here, you have an asymptote at -5. You have an asymptote at -3. Okay, so your graph goes somehow like this, somewhere down here, and something like this. Except my board is a little off. So something like this. So we have to see where this solution is. We want the positives. Kind of like what you do with your quadratic. You're looking to see where this is positive and where it is negative. So we want the positive sides. So to do this, we really don't have to look to see where the test is. We can see where this is going. We're going to look for your zeros of your numerators. We're going to put this on a number line first, and then we're going to compare it to your graph. So the zeros of the numerator says take those factors and set them equal to 0. Zeros of the denominator is the same as your domain restriction. So we found it to be x is -5 and x is -3. And we're going to put this on a number line. It's going to look just like this graph. Just like this graph. -5, -3, -1, 1. We just have a little problem with the open and the close. What happens in a denominator is that's your domain restriction. Can you ever use the ones in your denominator? Can you actually use those? No. So anything from the denominator has to be open. Kind of figure that it's on the thing. Anything from the numerator goes by this. So this is closed. Now, before we do our test for here, or actually, let's do the test because we may have to modify what our graph looks like. So let's do the test. Let's separate these into intervals. If I look at -6, and hopefully this will stay up here. If I look at -6, is the y positive or negative? Positive. If I look at -4, negative. If I look at -2, if I look at zeros, negative. And we'll talk about that in 1 second. And then I come down here and I find 1. 1 has my 0. We knew this was a 0. We knew this was valid. And 2 shows me positive. But when I look at my graph itself, I don't really see the negative part. I didn't see it jump down here. It looks like it goes all along. It looks like that. But it actually drops. If you want to see this a little bit better, sometimes you can change your window. Just make your y go from -1 to +1. We're going to find ways to see this pretty soon. But you're going to see, if I go from y to -1, did you see it drop down?
Yeah.
Your calculator can't be that exact. it looks like a line. Like sometimes, you know, when you do a radical, it looks like it just starts in the middle of the graph, like in the middle of the axis here. But actually, it rides all along here. It can't get any more exact. So sometimes, when we go to test, use your table. Because your table is going to show you where your values are. If you have to, do second calc, do a value. Like say you have a value between 0 and 1. Use this and put in 1/2 for this so that you actually see what's happening in between here. And you'll see what's going on. Not all the time does it look like our calculator makes it look. So in here, it's actually dropping down and then picking back up. We're going to see that a function can actually pass through. This is another asymptote we have. But we're going to see that it actually can pass through and come back up. It's designed so that it follows its end behavior. A vertical one can never cut through an asymptote because that's a domain restriction. But a horizontal one, and we'll look at these shortly, they can jump through. So you're really going to have to depend on your table to do this. The graph is a great thing to look at, but your table is what's going to help you through this. So now, you want all the positives. You want this one, and you want this one, and you want this one. So your solution says negative infinity to negative 5. This one has it's open. You have negative 3 to negative 1. This one at the negative 1 is closed. And you have 1 to infinity. Your denominators can never be closed. Your denominators, you can't use those. Those are domain restrictions. So right away you're gonna find those. Your zeros of the numerator depends on what that inequality is. If it just says greater than no equal sign or less than no equal sign, then they will also be open. Again, be careful of your graph. It's nice to know what it looks like. It's nice to know what we're looking at. And again, you didn't see this one here until we changed your table, right? It looked like there was nothing there. There has to be something there because it jumped over that asymptote and had to put it somewhere. So again, our table is what shows us this. Good? These are the tough ones. These are the tough ones. All right, let's try the next one. The first one, actually. The first one doesn't have a problem with the graph, but it does have a problem with the denominator, so I kind of wanted to do the other one first. Okay, domain restriction. Does anybody see a domain restriction here? Denominator. So we say, okay, set this equal to 0. And x cannot be 5. So our domain says jump over the 5. Now, according to your steps, you have to get everything to the left side. We have to have one term on the left side. God bless you. So subtract 3. Subtract 3, get everybody to the left side. This time, we're looking for negatives. Okay. Now, our problem is we have to make this one term. This is where the rational part comes in. So we find the common denominator. You can't multiply through a common denominator. You have to keep the denominator. We're just making the left side one term. So what would my common denominator be? X minus 5. So this guy has an x minus 5, so we're going to leave his numerator alone. This guy needs an x minus 5, so we're going to multiply top and bottom by x minus 5. And now you're just going to have to collect your like terms. Don't get rid of your denominator. This is not an equal sign. So we've got 2x minus 7 minus 3x plus 15. And I tend to write it out so that you can see the steps and my writing doesn't get too bad. But if you absolutely want to do this above this and then collect your like terms, I have no problems with that. I tend to like you to write this because sometimes when you do it in your head, you just miss that other negative sign, and then I have to mark it wrong because I can't see what you did. And collect your like terms. And that's about as good as we're going to get. Okay. So again, before we look at this, let's put this on our calculator. You can put in, if you want, there's a couple of ways you can do this. You can put this original one in, 2x minus 7 over x minus 5 minus 3. I'll show you a little hint. Put this in the way it is, the way you see it. You have to have it on one side. You have to have everything to one side. Now, if we did everything correctly, they should be the same graph. So in Y2, put this part down right here. It's got to be the same thing. If it's not the same thing, it'll give us two different graphs. And I want to make sure that I did everything right. So I can put this in my Y2 and make sure it's exactly the same. It's a nice way to check. I'm a big calculator checker. Oops, I gotta reset the graph. Sorry. Okay, so we can see that 5 is going to give us a problem, and the rest of the graph is looking pretty good. And the fact that we only have one graph, and our table is exactly the same, tells me, good job on converting that. Then I know everything went right. So I've got, again, an asymptote right here at the x equals 5. And this is probably going to drop down. It looks like it's dropping down. I'll be able to tell this by my table. When I look to the other side, I'll be able to see where my negatives go, or my negatives where my positives go. Okay? It just keeps on going down. So let's make this graph at 5. And did I say it was at 5? Your graph? And somehow it's going like this. So this is what our graph is. On your number line, set up a number line, and let's do zeros of the numerator, zeros of the denominator. So your numerator says negative x plus 8 is equal to 0, so x is equal to 8. And I can see that there on my graph. My denominator is the same as my denominator restriction. So I've got a 5 and an 8. Is the 5 open or closed? Open. Good. So my denominator. Is the 8 open or closed? Closed. Because that goes by this symbol. Okay. Now I'm going to section this off, and I'm going to test. I'm going to test using my table. I can kind of see this one. This one my graph shows me a little bit better. But just to make sure, I'm going to go to my table. I'm going to go to right before the 5, I'm negative. And yep, I can kind of see that there. From 5 to 8, I am positive. And from 8 on down, I am negative. Okay. And which one do you guys want? The negatives. This is what I'm looking for. So my solution is negative infinity to 5 or 8 to infinity. So again, find your critical values. Make sure you know where your denominator is. Your denominator restriction has got to be the open one here. Looking at this and looking at this is a little different. This one wasn't bad to follow because that graph, we could see everything that was happening to it. The other graph, we were missing the middle part, we were missing the part that it jumped over. So I suggest use your table. Graph it, look at what you're looking at, but use your table to find these. And you won't miss any of those little sections that don't appear on your graph. I think does anybody have a calculator that has the color in it? I think the color ones are a little bit better in your graph. I think their lines are thinner. So, because I remember last year some of the kids had the color one, and the color one like actually extended a little bit better. But these guys, they don't. Any questions? No questions?